Hi, Advanced Algebra 2B. So today in class we worked on solving quadratics. That's what it's called whenever you get a little squared up here. It's called a quadratic. Go ahead and write that down in your notes, please. And so we found that the first thing we have to do when we're solving quadratics is we need to get 0 on one side. So we're going to take 21 away from both sides, and we get x squared plus 4x minus 21 equals 0. And then we're going to factor this. That's the next step. So I need two things that multiply to negative 21 and add up to 4. Let's see. I know that 7 times 3 gives me 21. And, oops, that's not a 3. Let's see. And if I make this a plus 7 and a minus 3, that should work out, because plus 7 and minus 3 really does give me 4 in the middle. After I factor, I need to set each factor equal to 0. And then I need to solve. So I'm going to take 7 away from both sides of this equation, and I get x equals negative 7. And I'm going to add 3 to both sides of this equation, and I get x equals 3. Okay. So these are my two solutions. And then it's always a good idea at the end of the problem to check your work, to go back and make sure that you really did get the answer correct. And so if I grab my calculator out, I can plug in negative 7. So I'm going to put it in parentheses, square it, plus 4 times negative 7, and it should give me 21. So I'm plugging it back into the original problem, and sure enough it does. And then I plug 3 in to make sure it actually works, and sure enough it also equals 21. So negative 7 and 3 really do make this expression on the left equal to 21. Now, it doesn't matter which side of the equation you get the 0 on. So it doesn't matter if the 0 is on the right or if it's on the left. So if you see a problem like this, you could take x squared away from both sides and add 6x, but you're going to end up with some negative signs in funny places. It's going to make it hard to factor. So it's perfectly acceptable to leave the x squared on this side of the equation and take 7 away from both sides. It's all right to have the 0 on the left. So then I get x squared minus 6x minus 7. And again, I need to factor after I get 0 on one side. So two things that multiply to negative 7 and add up to negative 6. Well, that's going to be 7 and 1. And the 7 needs to be negative and the 1 needs to be positive. And then again here, I'm going to set each factor equal to 0. So x minus 7 equals 0, x plus 1 equals 0. And I solve each for x. Not too bad. You did a great job with this in class today. Now, if you see a problem where when you get 0 on one side, you have x squared plus 3x minus 5, and you're sitting here and you're trying to think of numbers that would work here, like 1 and 5. Well, let's see, if I put negative 5 on top of the x factor and 3. I know the only two numbers that multiply to 5 are 1 and 5. But there's no way to put 1 and 5 together and get a 3. I can't make them positive, I can't make them negative, I'm stuck. And so on problems that don't factor, you can always use the quadratic formula. It works every single time. So the quadratic formula says x equals negative b, or the opposite of b, plus or minus the square root of b squared minus 4ac, both over 2a. Or you might have seen it last year where it's one big division bar all over 2a. In any case, the a, the b, and the c are the numbers in front of the x squared, the x, and the just plain number. So for me, there's a little 1 here, so a is 1, b is 3, and c is negative 5. So I'm going to plug each one of these numbers into the quadratic formula. So let's see, x equals the opposite of b, so b is 3, so the opposite is negative 3, plus or minus the square root of b squared, so 3 squared, minus 4 times a times c, both over 2a. Okay. And then once you get here, we can start simplifying this down to figure out what x is really equal to. So I'm going to leave it as negative 3. 2 times 1 is 2. Now, underneath the radical, you want to do just the top side of the fraction first. So I'm going to do this off to the side. 3 squared is 9. And then order of operations, I need to do this multiplication. 4, well, you can think of it as -4 actually, times a -5 is a positive 20. So underneath this radical, 9 plus 20 is going to be root 29, and this is over 2. Now, you can actually stop here if you'd like, and you'd have two answers. X would equal -3 over 2 plus the square root of 29 over 2, or X would equal -3 over 2 minus the square root of 29 over 2. And in advanced classes, this is actually where you would stop. You would leave your answer with the square roots and the fractions, even though I know that that looks pretty crazy. You could also, however, figure out what your answer is as a decimal, totally acceptable, in which case we're going to grab the old graphing calculator, or just regular calculator, and I would do the hardest things first. So I would do the square root of 29, divide that by 2, and then I would add -3 divided by 2 to it. So I'm just figuring out what this is without having to write it down each time. And I get about 1.19. So I could also say X is about 1.19. And then I could do the same with the second solution. So I could say the negative square root of 29, because it's negative root 29 divided by 2. And then I could add the -3/2 to it, and I get -4.19. So the other way you could answer is using decimals and approximating your answer. Either one is fine with me. This one is more advanced, and this is one that you would see more often in story problems where you actually want to know exactly what your answer is. We're going to be practicing the quadratic formula tomorrow in class, so make sure you take careful notes and listen to this so that you can get off to a good start on the problems. And thank you for listening. Have a good night.